Welcome to the section on real numbers. To go through this, we're going to be working through A.11 on the Algebra 1 IXL. Just kind of describing what we're looking for and how to, as you read here, classify numbers. Oops, we don't want white right there. Something you can actually see. Maybe this one? There we go. So we're going to try to classify numbers. As you can see, we already have kind of this template, this chart laid out that describes the different classes of numbers, the different types of numbers that we're going to go through. And I want to give just a little explanation to those first, before we actually go through and start trying to answer the questions. So we have this overarching category, that's this biggest square here, of real numbers. That's our focus. If you notice outside, I have this term imaginary. That's something for later math classes, basically complex numbers, things that we're not dealing with quite in Algebra 1. So know that those exist. We're not going to worry about them for right now. Real numbers, our biggest kind of umbrella term out of everything that we're dealing with right now. Basically all the numbers that you know at this point. So that's kind of the biggest label that we have. Underneath that, it's broken into rational and irrational. Rational is essentially anything that can be expressed as a ratio or like a fraction, some number as a numerator and something as a denominator. Even if it's not shown as a ratio, if it could be represented as a ratio, it's still rational. Irrational means that it can't be represented that way. That's typically going to be numbers with decimals that go on forever and in no specific pattern. Pi is kind of the classic example for an irrational number because there's no set pattern to it and goes on forever. If you had something like a repeating decimal, like 0.11111, that's still rational. There's a pattern to it. Okay, after that we have another category inside rational, that is integers. Basically that's all of the numbers that you would typically use in math, at least up till this point in Algebra 1, of whole numbers that are positive and negative. So maybe it'll be smarter if we kind of start down here for this one. Natural numbers are the numbers that you would typically have learned to count on your fingers. So that's 1, 2, 3, 4, so on. Whole numbers, almost exactly the same except it includes 0. So 0 and then 1, 2, 3, 4, 5. Integers, what I was trying to explain before, is that it's 0, 1, 2, 3, 4, but also the negative versions of those. So -1, -2, -3, etc. Now that we have a little bit of a description, we can go through these and try to answer those. So which of the following describes 0? Select all that apply. So let's start with the smallest category and kind of work up. 0 did not fall under the natural category or the natural type of number. That's not one of our options, but just to kind of clarify, that starts at 1 and then keeps counting. Whole numbers, that's actually specific to 0. That's something that 0 falls under. If it falls under this category, well, it has to be an integer too, because that's outside. Has to be a rational number as well. You notice it's on the left side of this box though, over here, so not an irrational number. We could write 0 as a fraction if we wanted to. It would just be something like 0 over any other number, 1, something like that would be 0. So not irrational. It can be represented as a ratio. So that's what we would go with for that one. Okay. Which of the following are, all my drawings in the way here. Which of the following are real numbers? That's a 10 in case you can see that through there. Might have to get rid of this in a minute, but we'll see. So real numbers, we said that's everything that we know right now. So 4, even a decimal, 3.953, 5, and 10 is what that is. All those are numbers that we know right now. If they threw something with like a lowercase and italicized I at you, if you ever saw that's how they start to denote that imaginary number. Everything here falls under the real category. Is 8/9 an integer? So we said integers are whole numbers and they're negatives. So this would be like 0, 1, 2, 3, and so on, up as far as you can count. Integers would also be the negative versions. They're opposites, so -1, -2. Rationals is when we start to get into ratios like this, or fractions. So we're not quite there yet. So this is not an integer. It would have to be just 8 or just 9 or -8 or -9, something like that. Okay, that's a square root of 3. So we need to say which of the following is a natural number. So that's our smallest category. We said natural number is what we can count on our hand. Kind of when you're first learning to count, you probably don't even include 0 at that point. 1, 2, 3, and so on. You're probably not counting pi or a decimal or a square root on your fingers. However, 9, that falls under that category. Okay. Irrational. So basically something that we cannot represent as a fraction. Right off the bat I see this. I already mentioned that when talking about irrational. That's our go-to prime example of an irrational number, something that goes on forever with no repeating pattern. We can't write that as a fraction or as a ratio. 8/10, obviously already a fraction. 1/2, obviously already a fraction. -8, we could do something like this. Call that a fraction. You could even do like -16 over 2, and that would be the same thing. So we could represent that value that way. So these three, rational, the one circled, the pi, is irrational. Alright, let's clear those last couple things off. Is the square root of 3 a real number? So while that is a decimal, it's like 1.73. I had to get on the calculator. It keeps going. It still falls under the real category. So nothing imaginary thrown at us yet. I'm guessing that anything that IXL is going to throw at you is going to be real, but haven't ran into anything that's imaginary yet. Which of the following describes 8.5 repeating? Select all that apply. Integer, natural number, real number, and rational. I really need to move. I really should have put that somewhere else, but it's alright. So 8.5 repeating is not a natural number. That's not something you're counting on your fingers. Whole number doesn't involve decimals either. Integers do not involve decimals. Rational numbers, we could have that. So I'm going to go ahead and click that one. And then real numbers is even bigger than that. So we could go to that category. Awesome. Which of the following are integers? We just got done saying that integers do not include decimals. So it's not this one. That's the one that stands out. 1, 7, 8, those are all fine. We'll go till we get about the score of an 80. That's what I would typically ask for in class. So the following are irrational numbers. So pi is our prime example. I would want to check the square root of 46. And when I type that in my calculator, I see that, well, I guess I don't see any pattern for this decimal number, so I'm going to assume that's irrational as well. These two could be written as fractions, so they would be rational. You got it. Awesome. Okay. Which of the following is a natural number? So that's like our counting numbers. We're not counting with decimals or pi or another decimal. 84, however, yeah, it goes over your 10 fingers that you have, but we could keep counting up to 84, so that falls into the category. Notice that although this has 3 places after the decimal point, it does stop, so that's a key for us that it's rational and not irrational. Irrational has to have a decimal that goes on forever. Okay, so at this point we're at 72. We'll keep going. The following describes 0. 0 falls in everything on this left side except for natural. So that would be whole numbers, integers, rational. Which of the following are real? We've already said a couple times, everything we're dealing with in this one I'm thinking is going to be a real number unless they throw something that has like an italicized lowercase I next to it that represents an imaginary number for when you guys get to that in math later down the road. And probably going to need to do one more. 72 is natural. It's a number we could count to. That also includes the whole numbers. It also includes the integers. It doesn't have to be negative to be an integer. It just could be. And then irrational, it's not going to be that one because we could represent 72 as a fraction, put it over 1. We do like, what, 144 over 2, something like that. Awesome, so that makes it to 81. Alright, so hopefully that helped. My guess is this A11 IXL is going to be one that we're going through at the start of an Algebra 1 class. So hopefully it helped. Leave a like. If so, feel free to subscribe. We'll try to put a bunch of lessons on here. So hope everyone has a good rest of your day, and hopefully this helped you. See ya.